Hello YouTube and welcome. In this video we are going to do a 3D mesh-to-mesh mapping. In some simulations our analysis is halted by a mesh distortion error. It gets more severe if your analysis has multiple steps. So one way to solve such a problem is to change your mesh type or seed size. In most times we have to use a denser mesh or a more complex meshing. While this solves the problem, it is likely to make the analysis slower. Thus, you decide to run the analysis to some point with the old mesh, typically to the step where the analysis is error-free, and then change your mesh and continue. Therefore, a mesh-to-mesh mapping is required. Assume that we have a cylinder that is under tension. We decide to change the meshing to triangular. Since we want to continue the new analysis with a new mesh, we have to import the deformed state. We know that Abacus imports the orphan mesh, which is by default unchangeable. Next, we construct a body from the current orphan mesh. We do this using a plugin provided by the Dassault community. At last, we change the mesh and map the solution. Ideally, the results should be the same. However, in practice, there exists a little difference, so we have to check the results before we continue. Here I have a job that has been completed and the model is named old model, and as you can see a cylinder has been stretched and the Mises stresses are according to this legend. Now what I want to do is to change the meshing from this 8-node meshing to a TET mesh and continue my analysis for stretch, for shear loading, and I want to have this current state, meaning that at the start of my new analysis I have to have these stresses and strains. So what I'm going to do is that I'm going to create a new model named new model, and I'm going to import my part from my old model using the output database job 1, and I'm going to import the deformed configuration, as you can see it here. So this is the orphan mesh, and by default it is unchangeable. So here I'm going to construct a body using a plugin. Now I'm going to select my imported part, part 1, and I'm going to name the new imported part which has been constructed as new part. If you click create, it will take some time and create your new body. So as we can see it here, our new body has been created, but it is going to need some repairing. For this we are going to use the visual topology option and automatic create. Select our body and put some grid numbers, since I want to remove all the sections. As you can see, our body has been created, and now I'm going to change the mesh from hex to TET, and I'm going to use slightly less elements for time consumption problems, and I'm going to create my new body using my new mesh. Now I'm going to assign a section to this part, which is the old section, and I'm going to change the assembly options with this new part. I'm going to delete the old parts, and I'm going to apply the boundary conditions on the new constructed body. These are typical procedures. I'm going to do them as quickly as possible. So we have done all the things we needed to do in the Abaqus CAE. Now there's two more steps to make. First is that we want to map the solution and tell Abaqus to map the solution. For this we need to edit the keywords, and after the material section and before the step section we need to use a keyword. The keyword has been provided by Abaqus in section 12.4.1 as mesh to mesh solution mapping. There are a number of options, but I'm going to use the second option here. The difference between these two options is that the former resolves the unbalanced stress over the step, and the second one is going to do the job in the first increment. So I want to use the second option, and I'm going to use that after option and add the keyword map solution unbalanced stress at stress. So now I need to create a new job 2, new model, and I won't need to use data check or submit. I just want to write input here. So if I look at the working directory, job2.imp has been generated. Now I'm going to use Abaqus command, redirect to the working directory, and input these commands to start a new job. So basically what I did here is to introduce a new job into the solver and a new keyword old job 1 to tell the solver to import the results from previous job, which is here job 1, to the second job. Remember that if we want to use this option, we have to set the restart option in old model, which is going to be at the step module and restart request. Since we want to import the results, we have to check for restart option. Now if I click enter, there's going to be some running here. If I look at the working directory, I can see that job2.lck, which is the log file, has been generated, meaning that the solver is working on the part. And if we want to check the progress, we can always check the job2.log here. After waiting a while, we can see that the job 2 has been completed, and if we want to see the results, we only have to click on the results. And what I need here is to see my initial state in my current job to be equal to the ones in my old job. So I'm going to create a second window here, and I can see that the results from my old job at the end of my old job is almost equal to the results in the beginning of my new job. So this is called the map-to-map solution, and I can continue my new job using my new mesh, and I can hope that my errors, for example distortion errors or errors that are related to element distortions, has been resolved. This concludes our video. If you find this video useful, please support me by liking and subscribing to my channel. Take care.